In lesson 1-1, we are looking at solving linear equations, and I've provided you with our GRACE Mathematics Content Standard. This is not something that you have to record in your notes, but I do want you to know we do have a list of standards that we, as a math department, feel like that must be covered in Algebra 2, and that is what is going to be addressed today. You can see that on your screen. The objectives, you can just think of this as what it is that I want you to leave with the ability to do. Really two things. As you can see there, we're going to take verbal expressions, just regular words, and we're going to change those into algebraic expressions. Those are numbers with variables that include operations or exponents. And when we include the equal sign, then we have an equation. Without it, we just have an algebraic expression. And we can go the other way. We can take algebraic expressions and equations and change those into verbal expressions. That's what I want you to be able to do today, along with a review of what you probably learned in Algebra 1. How do we solve equations? How do we isolate a variable on one side of an equation? And the properties of equality, that's basically saying we're going to apply the same operation on both sides of the equation to maintain equality in order to get the variable by itself. Okay, so that's where we're headed today. And so I wanted to provide you with this video with some examples that will help you with certain homework problems, and I will always, with these notes, I will try to indicate the specific homework problems that my examples should be helping you with. So please don't just take these notes and forget them. Make sure you always write down what homework problems these are targeted toward, and I've tried my best to make these pretty close. Not exact, and they won't always be real close. I want you to have to think sometimes. But I've tried in this case to do some examples that match up pretty well with these particular homework problems. So my first example, we're going to address these 4 homework problems on your assignment. And so what we have here is a phrase, a word phrase, that we're going to convert, we're going to translate it into an algebraic expression. Okay, so let's just work our way through, and in some cases we have to remind ourselves what certain key words represent in terms of operations, or could be exponents. For example, just going left to right here, reading this phrase, I see the cube of a number. Well, a number in algebra, of course, when it's unknown, as it is in this case, it's just some number. We represent unknown numbers with a variable, and I'm just going to use the letter n. If you did this and you wanted to use x, that would be okay. It really doesn't matter what variable you choose. So this unknown number, I'm going to use n. When we say the cube of that number, that's like saying n to the 3rd power. Okay, raising something to the 3rd power is another way of saying cubing that number. Notice it doesn't say the cube root of a number. Some people get a little confused there. Completely different thing when we say cube root. That's using a radical, and you won't have to deal with that in this lesson. The cube of a number, and we're going to say n, increased by. That phrase increased by indicates an operation. And when you hear me use the word operation, you need to think one of 4 things: add, subtract, multiply, or divide. Okay, that's what operations, mathematical operations, are. Well, the phrase increased by indicates addition. All right. 4 times, that's pretty obvious probably. That indicates multiplication, the same number. So we've kind of talked our way through this, and we've highlighted key words and phrases that tell us about operations or exponents. So now let's put all this together into an algebraic expression. So the cube of a number, we already said that's the number raised to the third power. Increased by, that indicates addition. Okay, 4 times the same number. All right, we already said that 4 times, that's obviously multiplication. And in algebra, you probably remember that if we do a number with a variable right beside it and there is no sign in between, that always indicates it's assumed to be multiplication. Notice I didn't write N4. Some people just coming off the summer, coming out of Algebra 1, maybe a little rusty. I understand that this indicates multiplication, but the proper way, of course, when you have a number we call a constant times a variable, the proper way is to write this number first. We call that a coefficient. So if you're tempted, we'll try to make that correction early on. I know you've had the summer off, so maybe you've forgotten a few of the basic algebra principles. We'll try to give you a little reminder from time to time. So that would be our answer for letter A. So let's move down to letter B. This more than is very much, it's the same operation that we saw up here, increased by. Okay, notice what we did for increased by. We added this 4 times the same number. Well, I want you to think the same way. 3 more than, that's also addition. Okay, keyword, the quotient of, that indicates division. Okay, quotient is another way of saying division of a number and 6. Okay, so I'm going to do this fraction. It's a fraction is just another way of indicating division. The quotient of a number and 6. Okay, and then we're going to tack on this 3 more than. All right, so in other words, we're going to add 3 to this fraction, which is the number divided by 6, or the quotient of a number and 6. Okay, so n over 6 plus 3 is our answer for letter B. Okay, let's work on letter C. The product of, well, if you don't remember, just a little reminder, that indicates multiplication. That's a key phrase. The square of, all right, we looked at the cube of, that's raising something to the third power. The square of raises something to the second power. All right, just making myself a little note here as we go along. All right, the product of, multiplication, the square of, raising something, in this case a number, to the second power. Okay, so let's put it all together. And the product of the square of a number, all right, that number squared, and then this number squared needs to be multiplied by 12. Well, once again, if you're tempted to do this, because maybe that's the order that it's presented to you in this expression, that does indicate multiplication, and it's not terrible, but just keep in mind that the preferred order of this constant being multiplied times this variable is we put the number we call the coefficient in front of the variable. All right, now it's proper, it's in the proper format. We are showing that the number being raised to the second power is being multiplied by 12. All right, so now that we've had a look at this, we'll take just a minute in class, if you weren't in class, and I will, from time to time, we'll use this app on your computer called Socrative. It's just a good way for me to assess how everybody in the class is doing. So really all you'll need to do when you see this question come up on the board is key in to your app, and you'll see where that is. I will show you how we use Socrative, but for now just mentally tell or think about which letter you would choose A, B, C, or D to represent 6 more than a number. And hopefully, now that you've had a chance to look at all the options, hopefully you chose letter B. More than indicates addition, and we're adding 6 basically to this number identified as X. Okay, and then another one, just this is really for my sake. I want to know how we're doing as a class. The goal is for 100% getting this correct. So here's another word expression, 2 less than the cube of a number. Look over your choices and just mentally see if you can identify the one that represents 2 less than the cube of a number. And hopefully you successfully chose letter A, and that would be correct. All right. So that should take care of some examples. You should be good to go on problems 22 through 25. And now let's work on some examples for 26 through 28. These 3 problems really go the other direction. They're going to be giving you an equation. Notice the equal sign. So this isn't just an expression. This is an algebraic equation. And it's going to be our job in these 3 problems to translate this algebraic equation into words. Okay? And there's more than one way of doing this, and you'll still be correct. So what I'm going to do is just give you a typical answer to these, and if you came up with something a little different, as long as you've described the operations correctly, it's going to be okay. But let's just take a look at letter A. I noticed that first of all I'm subtracting. Just to give you a little tip here, I'm not saying you have to think this way, but what we're going to be doing in a little bit in this lesson when we start solving for variables, just want to remind you a little bit of something you've probably seen in Algebra 1, maybe even pre-algebra. This idea of PEMDAS. Remember the order of operations? If we were asked to simplify something algebraically, we would start by simplifying everything in parentheses first, and then once we take care of that, we would simplify exponents. Then we would take care of multiplication and division from left to right, and then last step, if we had any addition and subtraction, we would take care of those from left to right. Well, that was what we were taught when we are asked to simplify expressions. Well, when it comes to solving algebraic equations, we're going to start unlocking, or I use the term undoing, these operations, but we're going to go in reverse order. And we're going to see this in more detail in just a moment. But to try to get our way of thinking like this in preparation for solving for these variables and going in reverse order of PEMDAS, I like to think of these when I'm changing them into word form, and I like to go in this same order. So in other words, the first thing I'm going to write down is I'm going to indicate the subtraction. And one way of indicating subtraction in this case is by saying, using the phrase 3, the number 3, less than. Okay, when you see in this case, when it's an equation, you know that it represents an equation, then the phrase, those 2 words less than, will always indicate subtracting. Okay, we're subtracting 3. 3 less than. All right, now let's move to, we've taken care of the subtraction. Now let's move to the multiplication part of this equation. All right, so we can say 6 times, and then of course we're just saying a number in this case. And then since we do have an equation, we always let the word is stand for the equals. Is and equals are the same thing. And so we're going to say 9. Now if you used actual numbers here instead of words for these numbers, that's fine. But I literally used all words in this case to represent this algebraic equation. 3 less than, that's subtraction, 6 times a number, that's the multiplication, is or equals 9. Okay, and that takes care of my letter A example. All right, let's look at letter B. Well, let's see, what do we have here? We have addition, and I noticed that we have division. Okay, but here's something that's a little tricky, and I'm going to point this out again in some examples that we're going to do in just a little bit, because this does tend to confuse some people when we use this process of reverse PEMDAS. Okay, here's the problem. Here's the issue. When I divide 2 into this numerator, y plus 7, not only must I divide 2 into y, I also have to divide 2 into 7. Okay, I hope that makes sense from your previous Algebra 1 experience. I can't divide into individual terms without dividing into both. All right, we use the expression, I can divide into factors, but I can't divide into terms. Well, neither one of these are factors. They're individual terms that are being joined together. They're being added together. Okay, because of that, since I can't separate these when I do the division, then I really need to think of these as a group. Even though there are no parentheses showing, I always recommend that students in these division problems, okay, in division problems like this where there's a variable connected to another number with some operation, and it will either be addition or subtraction, these cannot be separated with division. When I divide, I've got to divide into both. Okay, here's the reason why I think the parentheses is necessary, and it will keep some people from making a mistake, because now we're going to think about undoing, and we're going to do this in just a little bit with some examples. But as we get our mind thinking about this reverse or opposite direction of PEMDAS, now I'm going to do what comes first, and I've really got two things represented in PEMDAS. I have division, and I've inserted my own parentheses. Okay, all right, so when I go to, in just a little bit, I'm kind of giving you a preview of where we're heading. When I go to solve for the variable, in this case y, I'm going to undo in this order. I'm going to undo the division first, and then I'm going to undo whatever is inside the parentheses last. So because I want you to get to your thinking like that for future problems that we're going to be doing, let's just word this in that same thought process of going in reverse PEMDAS. Okay, so let's represent in our wording first the division of. Okay, so, or you could use the quotient of. That's probably a better way of doing this. All right, so notice I'm using my words in the same order. I'm taking care of these word phrases using this reverse PEMDAS idea, because that's going to come in handy in just a moment. So giving you a little preview of what is coming. All right, so the quotient of the sum, that's, remember, addition, of 7 and a number, or you could say a number and 7, okay, the quotient of, that's my division, the sum of 7 and a number, that takes care of this numerator, and what I have in my parentheses that I inserted is 8, is the word that we use to represent equals. All right, the quotient of the sum of 7 and a number is 8. Very good. Okay, let's try letter C. And once again, we have a lot of things from PEMDAS going on in this equation. I notice subtraction, and I notice multiplication, and then I notice this exponent. So there are other ways, but since we're going to be using this idea of reverse PEMDAS to solve equations anyway, to isolate the variable, I just want to get you thinking about reverse PEMDAS. So let's start with a way to represent the subtraction. Okay, and remember that we saw this up here in letter A. We used 3 less than. Well, in a similar way, we're going to do 5 less than. Okay, that takes care of subtracting the 5. Now, let me erase my stars from the previous problem. The next thing I notice, if we took care of the subtraction, all right, that's gone. Well, here we have multiplication and power, or exponent. So now let's work on going in this reverse order. How do we represent, or how do we use words to show multiplication or to indicate multiplication? So we use the word times, or you could say the product of. I'm just going to say 2 times. Okay, that's easy enough. I've taken care of the multiplication, and now I'm ready to word the exponent, and we just say the square of. We saw that on the previous slide. The square of a number, since we don't know what that number is, it's a variable. And then for equals, I use the word is, and then of course 17. All right, so let's double check that, make sure I caught everything. 5 less than, that's my subtraction. 2 times, that's the multiplication. The square of a number, that takes care of the exponent, to is equals 17. All right, that's good enough for that example. Okay, and then I'm going to just fly through these. You'll have a chance in class to show me that you understand how to do those. So for sake of time, let's jump into some examples for homework problems 35 through 42. We're solving equations, one variable, and just remember, I'm going back, I'm stressing this way of thinking when you're solving for a variable, and that's just another way of saying isolate or get that variable by itself on one side of the equation. And the way we do that mathematically, maybe you never really thought about this before, the way we do that mathematically is we follow this PEMDAS. Remember, this stands for parentheses, exponents, multiplication, division, addition, subtraction. But we follow this PEMDAS in reverse order. So we're going to go up the PEMDAS order. So in other words, when I try to isolate x here on one side of the equation, in this case it would be the left side, I'm first going to undo any addition or subtraction that I see. I don't have any like terms to combine. If I did, I would do that before I even think about going through the PEMDAS reverse order. Don't have any like terms. I don't have any parentheses to get rid of using the distributive property, so I'm ready to undo operations. Okay, so in other words, the opposite of certain operations, and the ones that I do, the order that I undo them will be reverse PEMDAS. All right, well, I notice I've got addition, and the way that I'll just check off addition because it appears in my equation. The way that I undo addition is with subtraction. Okay, and so I know you've seen this in the past. I'm undoing adding 17, and I'm showing subtraction. Again, this is a property of equality. I'm doing the subtraction operation on both sides of this equation. Whatever I do to one side, I must do to the other side of the equation. And that gets me to this line, this equation, 3x. Remember, these will become 0, additive inverse property. And 14 minus 17, of course, is negative 3. Okay, now I'm left with multiplication times my variable, my unknown. And the way I undo multiplication is with division. So it's being multiplied by 3. Let's undo that by division by 3. And that's going to get me down to my solution. At least I think it's my solution. I want to have some confidence. So the directions are going to tell you to check your solution. Now, I'm of the opinion when you get to Algebra 2, I'm going to give you a little bit of freedom. I'm going to say if you check it, you're obviously going to have confidence that you're correct. Checking it means that you're going to come back into the original problem and you're going to just substitute, in this case, -1 for x. And you want to see if you get a true statement. Does the left side equal the right side when I substitute -1 for x? Well, obviously it does, and so I'm confident now that -1 is my solution. However, I get this question a lot. Do I have to check it? And to me, that's like saying, do I have to get it right? Well, no, you don't have to get it right. And I'm just going to say, if you don't check it and you do something, you know, people use this expression, I just made a stupid mistake. I guess they just mean a simple mistake, an easy addition or subtraction error. Well, those can be caught if you check your solution. So bottom line, I'm not going to ask you to show me on your homework paper that you checked. I'm going to leave that up to you. However, when your scores are low and we go back and we look at a test or a quiz and we see just saying, well, I understand it, but I'm just making those stupid mistakes. Well, you know, that's not gonna help you a whole lot. So just word to the wise, at the very least, I would say do a mental check. Whether you show it on your paper, that's going to be up to you, but you need to look in the mirror when you end up missing these, because you actually can know for sure whether or not you have the correct answer. All right, so that's my message for today. All right, letter B, same idea, except if you'll notice, we have what are known as like terms. What are like terms? You probably learned in Algebra 1. Like terms are terms that have the same variable, and not only that, but that variable has the same exponent. All right, so here's a pair of like terms, 8y and -3y. These would be considered like terms. And then there's another like term to go with those. Okay, I'll just put squares around all of the terms that we would consider like terms. They have the same variable, y, and y, of course, is to the first power in each case. So they are like terms. So the first thing that needs to be done, and I use the letters C, L, T. You'll see me do this quite often. That means the first thing, if necessary, that should be done in solving these equations is you should combine like terms. All right, so just going left to right, I've got 8 minus 3y, that's 5y. Now I'm taking 5y and I'm going to increase it by 2y. 5y plus 2y is 7y. And I'm bringing down the term, the constant 7, because it was not like the others. I could not combine it. Okay, so I've simplified. Simplify by CLT before you start to go through your reverse PEMDAS to undo the operations concerning y. We're trying to get y by itself. Okay, so I'll try to speed this up a little bit. There are two operations involving y. We have addition and we have multiplication. Well, if I'm going to go in reverse order of PEMDAS, that means I'm going to undo the addition first. And the way I undo addition is with subtraction. So my first move is to subtract 7 from both sides of the equation. I get 7y on the left. These will cancel or become 0. I get negative 28 on the right. Okay, that takes care of addition. Now I'm left with only multiplication. I need to undo multiplication by 7, and I do that with division by 7. And I get my solution for y equals negative 4. And if you wanted to take the time to check it, I'm not going to do that for this video, but you would substitute negative 4 in for each of these three y's. Okay, do the multiplication. Make sure that that left side of the equation, after you substitute negative 4, equals negative 21. All right, let's try another one. This time we have some simplifying to do, but it involves removing these parentheses, which indicates a number times this group in parentheses, and hopefully you recognize the need to use what we call the distributive property. Okay, I'm just going to make a little note here. The distributive property. The distributive property says this: I'm going to take the number, in this case 3, and I'm going to multiply it by both of these terms inside the parentheses. So don't forget that. It's easy mistake I see a lot is multiplying by the first term but not the second. So make sure you do it by both. 3y minus 6. Okay, here's another common mistake that people make. This is actually multiplying by negative 2. All right, negative 2 times 3y is negative 6y. Negative 2 times negative 1 is positive 2. Negative times negative is positive. Okay, so I have removed the parentheses in the original equation by employing the distributive property. And now I'll change colors since I'm going to change procedures here. Remember, simplify by CLT, combine like terms. I have a couple of like terms. I have 3y, and don't forget, this is negative 6y. 3y minus 6y, or if you want to change this to plus negative 6y, I'll leave that to you. But when I put these two terms, the y terms together, I get negative 3y. And I also have like constant terms, negative 6 and plus 2. Negative 6 plus 2 is negative 4. Okay, and now I'm ready at this point to think about PEMDAS in reverse. Just trying to drill this in your head because it really is going to come in handy with what we're going to do in example 4. So when it comes to y, I see two operations. I see subtraction. I'm just going to check that off because I see subtraction, and I see multiplication. So I'm going to undo these operations in order of reverse PEMDAS, starting at the bottom, working my way up. So the way I undo subtraction is with addition. Very important that we undo these operations in reverse PEMDAS order. Okay, so I get negative 3y is equal to 57. All right, and now I'm down to multiplication times my variable, and we undo multiplication with division. And my final answer here, remember, positive divided by negative, I get y as negative 19. I'm not going to take the time to check it. I hope you do, but you would need to replace both of the y's with negative 19, and you should get 53 on the left side after you simplify. All right. I got one more. This one involves fractions, so this one should be fun. Notice I've got the distributive property, just like we had on the previous example. Got to do the distributive property first. So some people struggle with fractions a little bit. That's why I wanted to do this example. There's a couple of ways to think about this. Let me just throw this at you and see if it makes sense. I'm going to divide 4 into 12. Okay, 4 goes into 12 3 times, and then I'm going to take 3, which is the result, and multiply by this numerator. 4 into 12 is 3. 3 times 3 is 9. So when I multiply 3/4 times 12x, I get 9x. Now you could have also thought of it as 3 times 12, which is 36, and then divide that by 4, you also get 9. So I will leave that up to you, but there's two ways of thinking about this. Here again, I'm going to do 4 into 16. I know 4 goes into 16 4 times, and now 4 times 3 is 12. I just brought the minus sign down. Okay, or you could have said 3 times 16 is 48. 48 divided by 4 is 12. All right, let's do the same thing over here. 3 goes into 9 3 times. 3 times 2 is 6. That's 6x. 3 goes into 6 2 times. 2 times 2 is 4. All right, and now we're ready to simplify. Before we start undoing operations, don't forget, we've already done the distributive property, and now we're going to do combine like terms. 9x plus 6x is 15x. Negative 12 plus 4 is negative 8. And I'm going to speed this up just a little bit since you've seen this reverse PEMDAS process already. I'm going to do undo subtraction first with addition. I get 15x is 30. And now I'm going to undo division, multiplication with division. And I get my solution, x is 2. Okay. So I just did 4 examples that should help you with problems 35 through 42 on the assignment. All right. Now we're just about done with this. This is an area that typically causes people trouble. We are still solving equations, but unlike our previous examples where we're actually trying to find the solution for a variable, like here I found that x, the solution, the number that x is the number 2. Well, in these problems, I'm basically just taking a given equation and I'm isolating the variable that I'm told to isolate on one side of the equation. Okay, but the thing to keep in mind is we're still using that reverse PEMDAS way of thinking. All right, so I always encourage students to take a look. I'm told to solve letter A for R. Well, let's take a look at what is being performed or what operations are happening around R. And this one's pretty simple. I've got multiplication really by 2 different numbers. I got multiplication by 2 and I got multiplication by pi. Okay, so when I'm looking at PEMDAS and I'm checking off what is happening to, in this case, R, well, there's really only one thing happening, and that's multiplication. I understand it's happening twice, but it's only that's the only operation that's being performed. So this one's pretty simple. How do I undo multiplication? with division. And you could take 2 steps to do this. You could divide by 2 first, then divide by pi. But since they're both being multiplied, let's just undo both of them at the same time with division. So to isolate r, I'm going to divide, the opposite of multiplication, by 2 pi on both sides of this equation. 2 pi divided by itself would just be 1, or we would say 1r, okay? And that takes care of what I was told to do. I've solved for r, I've isolated r, and the right side, the left side of this equation is c divided by 2 pi. Okay, and that is my answer. Okay, let's take a look at another example. Letter B says to solve for this variable b1. This is the formula for the area of a trapezoid. Not that you have to know that, but when you get into your science classes later on, this skill is going to be very important, that you can take a given equation, solve for a particular variable, and turn it around so that it's solved for a completely different variable. But once again, just remember PEMDAS in reverse. If you can remember that, it makes these really pretty easy to solve for. Alright, so I'm just going to circle B1 because that's what we're trying to isolate. So let's see what's happening around B1. Well, I noticed that first of all we have multiplication by 2 different numbers, 1/2 and this other number h. And then I notice also that B1 is involved inside parentheses. Now you might be saying, but isn't it being added? That's true, but I want to take the bigger picture. I want to, if you see an operation involved in parentheses, then just check off the parentheses and do whatever is in there as your last step. Okay, so let's work on undoing the multiplication. How do I undo multiplying by 1/2? Well, hopefully you're thinking, inverse property of multiplication. The inverse of multiplying by 1/2 is multiplying by 2. I think I'll just do this a step at a time. Okay, so my first step is to multiply by 2, and that undoes multiplying by 1/2. Alright, now I'm still on multiplication, okay, because I still have multiplying by h. How do I undo multiplying by h? Well, I divide by h. And I'm going to come over here. 2a divided by h is equal to b1 plus b2. Now, since there is nothing being multiplied by this group, I really don't need the parentheses any longer. Okay? So now I can take restock, I can kind of reevaluate my PEMDAS here, and what's left, what's the operation now that I'm showing? Well, now I'm showing addition, and how do I undo addition? Well, obviously that's with subtraction. 2a over h minus b2 is equal to b1. And that's our answer. We have isolated the variable b sub 1, which is what the instructions told us to do. So again, I encourage you to write this down every time or whatever it takes so that you can get a visual of actually checking off what's happening around the variable and undoing those operations or those parts of PEMDAS in reverse order. And hopefully that will help you. Okay, a couple more examples. This time we're asked to solve for a. Alright, so let's see. I'm just going to put a circle around a because I'm supposed to solve means I'm supposed to a should be all by itself on this right side when I'm done. Okay, so we're going to be undoing some things. So my next thing is I just like to observe, well, what's happening to A? Well, I notice that it's being multiplied by x squared, so I'm going to check off multiplication. I notice subtraction by two different terms, so I checked off subtraction. So let's start undoing in reverse PEMDAS order. And again, I'm going to begin with undoing subtraction with addition. Okay, so you can do these one at a time if you like. Okay. Okay, so what I've done here is I undid subtracting bx by adding bx to both sides. And then I'm still on subtraction because I notice that c is being subtracted. So now I'm going to add c to both sides. Okay, and all that's left now, I've taken care of the subtraction, undoing the subtraction. Now to get a by itself, I have to undo multiplication. And how do I undo multiplication by x squared? I divide by x squared. So this is going to be my final answer. Okay. And you might be tempted to cancel here. Some people are, but remember, you can cancel factors in these division problems, but you cannot cancel individual terms. So I can't cancel here without also canceling here and here, and since this isn't possible, I cannot do any canceling, so this ends up being my final answer. Okay, letter D. I'm supposed to solve for B. Well, just a word of warning here. Remember, we talked about this a few minutes ago. In these division problems where the numerator contains an operation like addition or subtraction, I strongly recommend, not everybody does this, but I strongly recommend that you put parentheses around this numerator portion. Why do I do that? Well, because it's going to help me remember the proper order to go about solving, in this case for B. I'm going to indicate division, and now I'm going to mark P for parentheses. Okay, if you don't, you're going to be tempted to undo what's in the numerator first because you're going to see addition, and that's going to trigger you to start undoing with subtraction, and that's going to get you out of order. Remember, this is all based on the fact that A, B, and C in this division problem cannot be separated when you divide by 2. They are in a group. They have to be divided as a group. So since they are connected and they need to be in a group to show the division, then let's just put them in a group. So the parentheses will be a big help, I think. So let's undo the division first. Division by 2 can be undone by multiplying by 2. And it makes these problems so much easier if you'll just remember this little step. Most of the time these problems will not have the parentheses. You just need to put them in yourself if you see an operation, add or subtract. And now it's pretty simple. If I want to solve for B, I'm going to undo the addition of A and C. And remember, of course, I undo addition with subtraction. And 2 steps, and we are done. We have solved for B. All right, very good. And by the way, that's an S. My S's tend to look like 5s. Okay, honestly, this is it. There's one problem in your homework that involves having the variable on both sides of the equation, so I just thought we would review that real quickly. remember, combine like terms. We already talked about that. So let's combine the W terms. 5 minus 12 is negative 7 W. And I don't have anything to combine with the 8 on the left side. I don't have any like terms on the right side. Okay, well, you probably remember this from Algebra 1. If your variable is on both sides of the equation, we need to make sure through the correct operation that we put it on one side only. So you may have seen this in the past. Whenever the variable, in this case W, is showing up on both sides of the equation, maybe you've had a teacher that has used this expression, kill the little one. Kill the little one. That sounds, I don't know, kind of violent. Well, here's what we mean by that. Which is the smaller of negative 7W and negative 15W? Well, hopefully you recognize that negative 15 is the smaller of the two between negative 7 and negative 15. So we're going to kill it. In other words, we're going to undo that one. How do I undo subtracting 15 with addition of 15W? And all that does is it keeps you away from having a negative number in front of the variable. So there are other ways, but maybe this would be helpful if you haven't seen that before. So now let's do combine like terms. Negative 7 plus 15 is 8W. Bring down plus 8. Over on the right side, I'm going to bring down 16. And then, of course, this is additive inverse. These are going to cancel each other. All right, and now I'm going to solve for W. We're back to what we were doing before. I'm going to undo addition first. And then I'm going to undo multiplication with division. All right, so I just wanted to remind you, when you see the variable on both sides, first of all, of course, combine like terms, and then you can kill the little one, whatever it takes, the inverse operation to remove the smallest one to create the variable so that it's on one side only. Okay, and this one is a lot like your number 56. You might want to use a calculator for this. I would not put one of these like this on your first test because you won't be able to use a calculator on your first test. But since it was in your homework, I just thought I would go ahead and do a similar one with you. So I'm looking. I don't have any like terms on either side. So now I'm going to work on taking the variable a off of one side and fixing this equation so that a shows up only on one side. So thinking about that little phrase, kill the little one, I'm going to undo subtracting 5.7. It's the smaller. Negative 5.7 is smaller than 7.6. So I'm going to add 5.7a to both sides. Okay, and if you want to grab your calculator here, 7.6 plus 5.7, and that is 13.3a. And I'm going to bring down minus 24.3 equals 3.9, and of course this becomes 0. Okay, and we're back to the old routine. I'm going to undo subtraction with addition. So I'm going to add 24.3 to both sides. 24.3 plus 3.9 is 28.2. Okay, and then I'm going to undo multiplication with division. So I'm just going to leave 28.2 in my calculator and I'm going to divide by 13.3. And in your book, yours is going to come out to be just a whole number. Mine did not come out like that, so you won't have to worry about rounding. I'm going to go ahead and round this to the hundredths place. But I just wanted to give you a heads up. If you need, may not need a calculator on this one, but if you do, it's okay for this particular problem. All right, so I hope these examples help you. You can see the assignment. It's also on RenWeb, and I'll make sure to tell you in class. But please practice these well, and you will be doing stuff like this on your first test, and let me know if I can help you.